Hi students, now we are discussing addressing modes or different types of addressing. Okay, first of all, what is addressing? Okay, when CPU needs any data or any instruction, it's definitely it should be in main memory. So CPU has the locations or CPU register have the locations of the main memory which have the instruction or data. Okay, so the addressing is used to find the data, okay, from the correct location of main memory. Then there is many types of addressing. Okay, addressing means the way in which the CPU, okay, CPU finding the data in the locations. Okay, mainly there are many types of addressing modes. We mainly uses immediate addressing mode, then direct addressing mode. These are some popular addressing modes: indirect addressing mode, then registered direct addressing mode, then register indirect addressing mode, and then indexed addressing mode, and base register addressing mode. And these six are common most popular common addressing modes. Okay, let's discuss about immediate. Okay, let's discuss first we discuss immediate addressing mode, then direct, then indirect, then register direct and register indirect, then indexed addressing, then base register addressing. Okay, let's go to immediate addressing. Okay, as mentioned, the operand is specified in the instruction explicitly. It means in the instruction itself, the value is the operand. You should know what is operand and opcode. Opcode means operation code. Which operation which operation will be done? It depends on the opcode. Okay, and operand is the which variable takes part or which value takes part. This is called the operand. Okay, it may be 1, 2 or 3, it may be many. Okay, so in immediate addressing, the operand is itself in the instruction. Okay, first the CPU got the instruction from instruction register. Okay, then instruction register, then our control unit decode the instruction register and find the opcode and define the opcode and operands. Okay, when the control unit decode the instruction register or decode the instruction from instruction 1, let instruction 1 is decoded by control unit. Okay, the control unit get the instruction or decode the instruction, then we find that immediate addressing or direct addressing, this find the modes. Okay, when control unit decode this instruction, the instruction itself have its operand. Okay, the instruction itself have the variables that it needed in the operation. Let's say example 200 plus 300. Okay, then we have I can say I have direct values of 200 and 300. I have direct values of these operands. It's operand A and it's operand B. I have direct these values, immediate values. This is called immediate addressing. Okay, then let's go to direct addressing. Let's go to direct addressing mode. Okay, in direct addressing mode, okay, first you have to understand direct addressing means the operand address is given in the structure. Before the direct addressing mode, in immediate addressing, the operand value is itself given in the instruction, but in direct addressing, the operand's memory location is given in the instruction. Let I say A plus B. Okay, A is a memory location and B is a memory location. Okay, let A value 200 and B value 300. Okay, so I don't give 200%, I give A plus B. Okay, it's also called direct addressing mode. It is also called direct addressing mode. Okay, here is some notes. You can write it. here is some instruction format. This is the opcode, is the operand. It's the operand variable a and a referencing to memory location where a operand is present. Okay, this is the memory location. Okay, let me erase. This is the memory. Okay, and here is the memory location where the operand is present. Okay, clear? Next, move to indirect addressing. In indirect addressing, this is the instruction format. Okay, this is opcode and this is operand. We need the operand. It is not the operand's address, it is a address of a memory location. It is address of a memory location. This is a memory and this is a memory location. From this location we get the address of the operand. From this location we get the address of the operand. From this location we get address. From address we get the operand. Okay, if you want more clearer, then let's go example. Here is some instruction format. It's instruction format, not instruction page. Okay, from instruction format, this is opcode, and this is operand's address. Okay, but this is not the operand's address, this is the address. We go to this 100 address, then we find another address 200, then from 200 we go to 200 address and we finally found our operand value. Okay, this is immediate addressing. Then next, move to register direct addressing mode. Okay, before we discussed about direct addressing mode, and this is similar to the direct addressing mode. Register direct addressing means, okay, we taken the example a plus b. Okay, a is a memory location and b is a memory location. Like that, in register direct addressing, if I'm writing a plus b, then a is a register and b is a register. Okay, it's simple. Okay, in direct addressing mode, the instruction have operand address, operand memory location, but in register direct addressing mode, the operand location is in the register and the register address is given. Okay, the operand is in the register and the register address is given. This is called register direct addressing mode. Okay, it's clear? Then let's move to the another section. Register indirect addressing mode. Similar to indirect addressing, first this is our instruction format. Okay, this is a address, this is a register address. We go to register address, then we find a address. Then we go to this address in the memory location and found the operand. This is that much simple. Okay, I will discuss it again. This is our instruction format. This is instruction operand. This is opcode. Okay, let's make it clear and let's write it register R1. Okay, register R1. Then we move to register R1. Okay, then from here we get 100 memory location. Then let's 50, 100, then 150, then 200. These are some memory locations. Okay, this is our 100 location. Okay, we move to 100 location to this location, and in 100 memory location we get the operand. Okay, this is called register indirect addressing. Simple. Then we have index, let's move backward. Okay, here's index addressing mode. Okay, what? Index addressing mode. Okay, in index addressing mode there is a it is our instruction format. Okay, this is opcode. Okay, and this is a memory address. Okay, this is a memory address, this is a memory address, and this is index register. Index register. Okay, this is memory address of a. Okay, how can we find the another operand? We just add memory address a plus the index register value. Okay, then we get our b value. Okay, in index addressing mode, making it more clear. Okay, I am making it more clear. We are discussing index addressing mode. I have my instruction format. This is opcode, opcode opcode, and this is our operand a, opr a, and this is a offset value. What? Offset value. Okay, this is also called index register. Index register. Okay, then what happen? We have operand a address or a address. We have to find b address. How can we find? We find b address by a address plus offset value. Okay, index register value. Okay, when we add a address and index register value, this is index register value or offset value. Okay, this is index register value or offset value. Then we get the b variable or the second operand value. This is in indexed address mode. Then next move to, okay, let it clear. The next move to base register addressing. Okay, base register addressing. This is our instruction format, same as like indexed addressing mode, same as like this is our opcode. Okay, and this is a base register. Okay, and this is address, a memory address. Okay, memory address. So how can we find the second operand? We just find the second operand by adding the both. Okay, this is the technique of base register addressing. Thank you.